We'll proceed in vector and commercial calculus. Vector and commercial calculus, long discussion that we are pursuing. Vector and commercial calculus. So in that sense, we have done a very big analysis on energy calculation, that is force vector dot displacement vector. If you have a force vector comes into practice because there is some energy source. If there is some energy source, then certainly there will be a force vector, and through the force vector, energy source works. Okay, so all around there is a force vector, all around. Okay, if you don't believe me, then I just leave it. Because of the force vector of Earth, this item moved one location to another location. There is energy. There is energy force. Because of there is one energy source, that is Earth, and because of the energy source, there is a force vector all around the Earth. If you place any item, then energy, the force vector will will move it to one location to other location. Force vector is toward the earth. It is not outward, it is toward the earth. If you place something, then it will start moving toward the earth, means earth is losing energy and force vector is working on it. Okay, so working on something never means that you touch it. If you touch it, then it will move. It is not required that you always touch it. Through the force field also energy. If I am energy source, and if there is an item and if I push through my hand, then it is moving. Or if something is moving, means I am losing my energy. That energy I am making it move from one point to another point. But not required that always all every time the energy source need to touch the item. Because of the force field also it moves. This is what we have seen. Okay, okay. Earth makes anything move, right? If I have a magnet and if I keep one wood, then wood magnet would not lose energy on wood. If I keep an iron, then iron will move toward magnet. Iron will not move toward magnet. The magnet's magnetic force will make item move from one location to another location, and magnet is losing energy. Magnetic field is going away. Okay, so magnet works only on iron. It does not work on aluminum. It does not work on gold. Earth field, Earth force field is more powerful. It works on everything. Is it really true? Earth field works on everything. Is it really true? Not true. Earth does not work on electromagnetic radiation. If electromagnetic radiation is passing through, either it is sunlight or anything else, then Earth does not work on them. There are two terminologies. One is Newton's terminology, where Earth cannot pull it. Gravitational pull of the Earth does not work on electromagnetic radiation. There is Sir Einstein's theory, Sir Newton's theory, and Sir Einstein's theory. Sir Einstein theory talk about energy. Earth energy, Earth force field. Earth do not work. Earth do not lose energy if there is any electromagnetic radiation passes through. It won't. Electromagnetic radiation won't get deviated. If it is getting, if deviation is seen in electromagnetic radiation when it is passing through Earth, means Earth is losing energy. Earth is working now, but Earth is not working on electromagnetic radiation. Thanks God. Otherwise, the television and nothing will work, because every electromagnetic radiation will be pulled by Earth. Okay, what are you talking about? Electromagnetic radiation cannot be pulled by anyone. Okay, either it is Earth or it is Sun. If you pass the electromagnetic near to Sun, also it won't attract it. I mean, Earth energy will not. Earth energy force field will not work on it, guaranteed. So, Sir Einstein has said that electromagnetic radiation or sunlight, whatever, 3000 kilometer per second. That is the maximum entity on in this planet. This is completely wrong. Means very sad to say that, but it is completely wrong. Sir Einstein says that the electromagnetic radiation, I believe 3 into 10 to the power 8, 3 into 10 to the power 8 is the highest possible speed in the universe. That is the speed of the light, that is electromagnetic radiation. That is, this means that whatever star we are seeing, that is 1000 light year away from us. If light is reaching to us, then 1000 year is over. Not we are seeing a star in the sky at that moment only. Okay, anyway, I can give a theory of it, and I have given, you can watch video for that. But certainly I can say that electromagnetic radiation is not the fastest fastest entity in the universe. 100% true. Now the scientists, they have also proved that, okay, anyway, if I have a magnet, the magnet cannot attract wood. Means magnet, the force field of magnet is small, but earth can attract wood, iron, gold, everything. Earth force field or earth energy is higher. Okay, if sun energy is higher to earth, then there would be something that earth do not attract, but sun would attract, or sun works on it. There is something called black hole also. Black hole around which sun rotates, that is center of Milky Way galaxy. Black hole, and there is nothing like black hole. I believe small black hole someone can see, but black hole presence is much more powerful than someone can see. Black hole can attract light. Black hole can attract light, means black hole, nothing escape from there. If there is a electromagnetic radiation someone is throwing, and considering that it he will receive on other side of the black hole, not possible. Black hole will attract electromagnetic radiation also. If this is true, then nothing will come to our eyes at all. If any star is other side of black hole and we are trying to see that star, then black hole will attract all the light that is coming out from the star. And what 1000 year that star light will never reach to our eye, but that is not true. Okay, if someone is seeing all the star in the sky, and many stars are kind of galaxies also, like Andromeda galaxy, it looks like a star, but if someone do binocular on it, then he will see tons of a star in that. That is a galaxy. And this big, if it passes through, it may pass through many black holes in between, and that Andromeda galaxy can never be seen. If that is true, then certainly electromagnetic radiation is not the fastest radiation in the universe. Okay, what I'm trying to say is, okay, anyway. So, whatever energy source we have, it works on some item, not on every item. Depends upon the power of energy source. Anyway, so we started the discussion with the energy computation. If there is energy source, there will be force field around it. If there is a force field around it, if it works on certain item, if we keep the certain item in the electromagnetic force, then it will make item move. It won't attract it. This is Sir Einstein's theorem as per the energy theorem. It won't attract it. It will, because of the force field, the item will start moving from one location to another location. If it is moving from one location to another, if a car is moving, if a car is moving from one location to another location, and I would say it is free. See, my car, I mean, I don't have any car work. A car moves from one place to another place. See, so nice, right? It's not free. Someone burned because of you. Means someone lost energy because of you. Who lost the energy? The fuel that is inside the car. It lost the energy. Because of that only car moved from one location to another location. If I leave this and it moves one location to another location, then some energy got lost in that. And Earth lost the energy. Earth lost the energy the way the petrol or diesel got burnt out in the car. It lost the energy. That's why car is moving from one location to another location. Similar way, if this is moving from one location to another location, then Earth is losing the energy. Okay, it is a different matter. The Earth loses energy, Earth receives energy also. And that's how it is the way it is always. Whatever the Earth looks like, it looks always the same. So force vector is dot product with displacement vector is the energy calculation. Anyway, or or if we go with the integral calculator, force vector dot d of position vector is is the energy calculation. Anyway, now we are in phase of calculating flux. Flux means if I have a liquid that is flowing through a surface, then how much is liquid coming out of the surface? The velocity of the liquid into surface area. That much is the flux, or that much is the volume per second would come out from the surface. Or velocity vector dot area vector. This is what we are talking. So if this is okay, so if this is velocity vector and this is area vector, oh, I'm sorry, this looks like area. If this looks like area, then certainly there is area vector. If this looks like area, then certainly there is area vector. Area vector is perpendicular to the surface. It can be in this direction, it can be in this direction. Which direction we are taking depends upon what is the direction of this curve I am taking. This is a curve. This is a this is a line that is around this rectangle. This line is oriented in what direction? If it is oriented like this, then this looks like it is anti-clockwise. If it is anti-clockwise, then generally people they use this kind of thing. So, okay, hop. If it is like this, then it will go in this direction. I mean, then it is other way. Okay, so this looks like if it is orientation is in this way, then normal is this way. Makes sense? Now, there is a velocity vector. Fluid is flowing, a big fluid is flowing, and it is hitting the surface. If surface vector and fluid vector are in same direction, velocity into surface area is the net volume of the liquid that is coming out of the surface. Or, or velocity vector dot area vector. Velocity vector means if velocity is in this direction, then how much angle it is making from the area vector. If this is the area vector, this is the area vector, and this is velocity vector, then through area vector, how much velocity vector is making angle cos theta of it, or velocity vector dot area vector. That is the flux. Okay, we moved forward and then we said no. If velocity vector itself is not straight, it is a algebraic vector. If area vector is also algebraic vector, area vector algebraic vector means area vector is not flat. It is curve 1. Area vector is curve 1. The way, like we say, our area vector is this full sphere. Now, the surface of this sphere is the area vector. The surface of this sphere is the area vector, is the area. Area vector is perpendicular to the surface. Then area vector will change as we move because everywhere perpendicular is different. And this line, if you pierce it, it will go exactly meet the center of this sphere. So, so this area cannot be straight, flat. This is changing everywhere. This is algebraic area. Algebraic area means if this is xy plane and this surface area, if I keep here, then if I keep here and the center of this is origin, if I keep on the center, then if I take different x and y, this is xy plane, if I take different x and y, and for that x and y, if I take height and it touches a point here, then for different x and y, different point will be touched. And at different point, different normal is there. So the surface normal or surface area at surface normal or surface equation at any point is dependent upon x and y. This is what we have seen. In that case, when velocity vector is algebraic, we have given example of velocity vector that is algebraic. Like an electric charge is kept at the center of this ball. If there is an electric charge that is kept at the center of this ball, then there will be electric field all around it flowing outwards. How much electric field is flowing through this surface, out of this surface? Flux of the electric field. Then electric field is Q. Then electric field, the velocity vector, okay, liquid velocity. Consider from the electric charge, liquid is flowing outwards. Then what is the formula of liquid? Q charge into R vector divided by R to the power 3. If you go along distance, then the charge velocity, liquid part or the electric field will decrease in a square fashion. That is the sense. So this is algebraic equation. The velocity is algebraic equation. Q R vector, that is xi plus yj plus zk divided by r to the power 3, x square plus y square plus z square to the power 3 by 2. Okay, this is, so velocity vector or liquid velocity, that is all around, is algebraic. Surface area is algebraic. If that is the case, the net flux coming out of the surface area is velocity vector dot d of position vector of the surface area. Same thing we have seen in the two dimension also. If there is a force field like this, then how much is the energy calculation if one item moves in circular direction from one location to other location because of this force field? Force field vector dot product with the displacement vector, or force field dot product with d of position vector. Similarly, here the velocity field dot product d of position vector of the surface area. D of position vector of the surface area. Anyway, now we went forward and we saw that it is velocity vector dot d of position vector become dp by dx cross dp by dy dx dy. And we gave example of a flat surface also. If there is a flat surface and okay, so if this is x-axis and there is a flat surface kept on the x-axis, this is origin. If this is origin and this is x-axis, then this is z-axis, this is y-axis, this is x-axis. Now this is tilted like this little bit. If it is tilted like this, then if I draw a line here and it cut y-axis, this length is 1, whereas this length is 1, whereas this height is 3. We gave this example, and there is a, okay, if this is x-axis, it is like this. Now I rotate it. Now it will be quite clear. This is like this, where this is x-axis, this is y-axis, this is z-axis. It is like this. Now this point that is toward the origin, this point is 0 comma 1 comma 3. This point is 1 comma 1 comma 3. This point far away from the x origin is 1 comma 0 comma 0, and this is origin, that is 0 comma 0 comma 0. Now we calculated the surface area vector. Now big discussion, the big research happened. How? Velocity vector I know, q into r vector divided by r to the power 3. That is velocity vector. Q into r vector divided by r to the power 3. What about the surface area vector? That is minus dz by dx minus dz by dy plus k, I'm sorry, minus dz by dx. The surface area vector is d of position vector. Surface area vector is d of position vector. That is dp by dx. D of position vector, velocity vector dot d of position vector. D of position vector is d of position vector by dx cross d of position vector by dy dx dy. This is what we saw. And if someone settle down dp by dx, position vector is xi plus yj plus zk. So d of xi plus yj plus zk by dx cross d of xi plus yj plus zk by dy. If someone settle it down, it becomes I plus dz by dxk cross j plus dz by dyk, and it becomes minus dz by dx minus dz by dy minus dz by dxi minus dz by dyj plus k dx dy dx dy, and this is what that is the surface area vector. Pull dx dy along with pull d of p, d of surface area position vector broke into dp by dx cross dp by dy dx dy, that finally broke into minus dz by dxi minus dz by dyj plus k, and in braces dx dy. This becomes the d of position vector. Okay, that big it is. Anyway, now someone would say, boss, I don't understand this. This is very difficult. Okay, I know that the flux is velocity vector dot d dot area vector. Velocity vector dot d of area vector. That much I know. Velocity vector dot d of area vector. Okay, if I d velocity vector dot, I'm sorry, velocity vector dot area vector, velocity vector dot area vector. So can you calculate area vector in little bit easy way? Okay, this calculus looks like very difficult. Is it possible? Okay, I can make someone understand in easy way. What is area vector? If there is an area like this, if there is area, this is x-axis. This is x-axis. Hope, I believe I could do it. I can do it. So this is y-axis. This is x-axis. This is x-axis. Hope. This is this is x-axis. This is y-axis, and this is z-axis. Now, if that is the case, what is the area vector? Area vector is perpendicular to the surface. This is area vector. Area depends upon the orientation. If orientation is clockwise, then oh no. If orientation is anti-clockwise, then area vector will be like this. And this side area vector will be like this. Okay, this is area vector. Since this is a flat surface, area vector everywhere it will be same. But here, if you see the area vector of a sphere, since it should be perpendicular to the surface, everywhere area vector will be different. Depends upon the point I am taking. Now, let's take, okay, now what will be the area vector if I calculate in a layman's term, not by minus dz by dxi minus dz by dyj plus k. Okay, that is a big term. What it resolved in that? If you remember, in past video we have talked about it. Minus dz by dx was 0. Minus dz by dy was 3. Minus 3j plus k. The area vector what we got was minus 3j plus k. Okay, through the calculus fundamental. Dx dy. Okay, here if I am trying to calculate the area vector of this that is perpendicular to this, then area vector will be only one. Whatever I am going to talk now, it is not available in any of the book to make things simpler. Okay, can you tell me the vector that is along the surface? Okay, like here there are two vectors involved. One vector is perpendicular to the curve, that is called position vector also, or whatever it is. Every moment there is one vector that is exactly perpendicular to the curve. there is one vector that is along the curve. This along the curve is also called tangential vector or curve vector or displacement vector. Otherwise, this is normal vector at that point. Similarly, if there is an area, then this is for area. This vector there is a, if this is the area, then the vector. If I'm trying to name this area with through a vector, then it's not possible because this can be a vector on the area. This can also be a vector on the area. This can also be a vector on the area. This can also be a vector on the area. 360 degrees because it is an area. It is not a line. Okay, but if I nomenclate, if I do nomenclature of the surface area as a vector that is perpendicular to the area in this fashion, then it is unique. Everywhere this perpendicular vector is unique. It is parallel to each other everywhere. But if I talk that surface area vector is along the surface, then it will not be unique. All are along the surface. But if I see the perpendicular, that's why surface area is perpendicular to the surface, whereas displacement vector is along the displacement. The two dimension and three dimension is different. Anyway, the flux is velocity vector dot area vector. Can you get the area vector? Okay. Now, if this is now someone has to watch very clearly. Okay, now consider this is x-axis. If this is x-axis and then this is y-axis. This is y-axis. This is y-axis like this. Then this is z-axis perpendicular from origin perpendicular here. If I show like this, then this is z-axis. Now, if it is tilted like this little bit, it is tilted little bit. Okay, along x-axis, this is 0, comma 0, comma 0. This is 1, comma 0, comma 0. This is 1, comma 1, comma 3. And this is 0, comma 1, comma 3. Now, there are two planes, they are unique here. One is called xz plane. If this is x-axis, this is z-axis, then there is a plane called xz plane. There is a plane called xz plane. Similarly, there is something called yz plane. There are two planes here. This is x. If this is the surface, then this is xz plane. This is xz plane. Okay, if it is xz plane, here this line is on xz plane provided y equal to 1. Because if I cut in xz plane, there will be a fixed y. At this point, that is x-axis, if I cut xz plane, then where y equal to 0. If I cut here xz plane, then here y equal to 1. xz plane. Similarly, if I cut here along the y-axis yz plane, then x is 0. If I cut yz plane here, then x is 1. Okay, I believe it is all right. Now, consider that I'm trying to find the surface. I'm trying to find the area vector at origin. At origin, area vector is like, if it is a flat surface, then area vector will be same all around. Let's try to find area vector at the origin. At the origin, what? Okay, area vector. If I see, then area vector. Consider there is a two vector. This is one vector, and this is anywhere in the space. This is another vector. This is not straight. If you see, it is little bit curved. Okay, what is area vector for these? If I do cross product of these two vectors, then if I make a surface like this, touching this line and this line, I can create a surface. If I create a surface touching these two lines, then area vector will be perpendicular to the surface. Then, then area vector will be perpendicular to the surface. If this line is like this, then area vector will be perpendicular to the surface. And the area, that is the area vector direction I am talking about. The area is cross product of this vector and this vector. Okay, if there is an angle between it that is not 90 degree, then it will be area of a parallelogram. Otherwise, if it is 90 degree, then it will be area of a rectangle. Cross product of two vector is the area, and area of direction, area vector direction is perpendicular to the surface. Makes sense? Now, if I'm trying to calculate the area vector of this surface at origin, other point it may differ, but in this example it will not differ because the sides are parallel to axes. This side is parallel to x-axis, and this side is parallel to some line. This side and this side, they are parallel to some line. They are not like this or like this or something like that. So now in this case, whatever it is, I'm trying to find the area vector at the origin. This is x-axis, area vector at the origin, and same area vector will be other places also. Now for this area vector at the origin, I'll take two vectors. This is one vector and this is another vector. If I do cross product of these two vectors, wherever it is, I don't mind. It is like this. If these two vectors, if I get the cross product of these two vectors, then it looks like it is going like this, but I'm talking about at this point, at origin only. At origin only, I take a kind of two vector. One vector is in xz plane and one vector in yz plane. If I do cross product of these two vectors, one vector, or you take any point here, any point P here, and then cut in xz plane, cut in yz plane, cut in xz plane, and cut in yz plane. In xz plane, it will come like this, and in yz plane, it will yz plane, whatever. If it is yz plane, it will come like this, I believe so. Whatever it is. So if you do cross, let's try it. If I do cross product of these two vectors, then see what's going on. Okay, so let's try. So let's try what is the vector along the xz plane. If I cut any point on the surface, I can cut it in xz plane. Any point on the surface, I can cut in yz plane. Now along the xz plane, along the xz plane, see what is the take one vector. Along the yz plane, take one vector. I think it will be more clear once we proceed. Now, what along the xz plane? Hope. Now consider this is, I'm trying to calculate surface normal at the origin, that is in this direction. Now I'm taking one vector in along the x-axis. What is the equation of this vector? This vector equation is origin and 1 comma 0 comma 0. This line, equation of this line in xz plane, equation of this line in xz plane, because the surface, the line that is from origin, the surface is passing like this. So this line along the origin, it is passing 0 comma 0 comma 0 and 1 comma 0 comma 0. Okay, if that is the case, then the equation of one vector is I vector, simple I vector. We will proceed on this. Okay, now what is the another vector? That is, it is a straight line. So another vector here, it is passing 0 comma 0 comma 0, and another line it is passing as 0 comma 1 comma 3. If I am kind of deviating in xz plane, yz plane, we will settle down. Now we are trying to calculate the area vector. This area vector is cross product of this vector and this vector. If it is not yz plane, then we will settle down. For right now, let's go by the numeric method. So xz plane, yz plane, for time being, just curve on it. So if this is the surface area, if this is a surface, and I'm trying to find the surface normal. Surface normal will be if I take any two vector in the surface area. If this is a vector and this is another vector, if I do cross product of it, I'll get the surface area vector. As per the cross product fundamental. If I take any two vector on the surface, this vector and this vector, if I do cross product, I'll get the surface area vector direction in this direction. Okay, means but the actual area will be in between it only. But if I want full place surface area, Then one vector I'll take in this direction and one vector I'll take along another direction. If I do cross product of it, I should get surface area magnitude also and direction also. This area vector is I-axis because it is along I-axis. This area vector if I take, then this is origin and this is 0, 1, 3. Then this vector will become j plus 3k. I believe I'm alright. One vector is I-axis because it connects 0, 0, 0. Another is 1, 0, 0. Another line that it connects two vector I am taking on the surface. One vector is along this side and another vector is along this side. Then I'll do cross product. And these two vectors are taken from the origin only. So at origin, this vector direction is along x-axis, so I vector. This vector direction is along this surface that connects origin and another point 0, 1, 3. So this numeric vector is j plus 3k. Now, if you see what is your vector along the surface, this what I am going to now calculate is normal vector. Normal vector is perpendicular to the surface, but right now we are trying to calculate perpendicular at the origin. Surface, but at the origin. What is the vector along the surface? All there are numerous vectors that is falling on this surface, but we have taken two of them. One is along this side, another is along this side. One is I vector and another is j plus 3k vector. Now calculate the cross product to get the area vector at the origin. Then cross product of I vector cross j plus 3k vector. J plus 3k vector. J plus 3k I cross j plus 3k. It will become I cross j means k and I cross k means minus j. It becomes minus 3j plus k. The area vector at the origin, since it is flat and oriented in same direction, area vector at origin will be same as other vector also. So surface area vector, so easily I found it is minus 3j plus k. Otherwise, surface area vector is minus dz by dxi minus dz by dyj plus k. Okay, now dz by dx minus dz by dxi minus dz by dyj plus k is the area vector. Now if I move along x-axis, then how much z we are moving? 0. So dz by dx is 0. If I move along y-axis, then how much z is changing? Then z is changing 3 if I move 1. dz by dy is 3. Then area vector is minus 3j plus k. Same thing what we are getting to cross product I vector and another vector is j plus 3k. If I do cross product of I vector cross j plus 3k, it becomes minus 3j plus k1. Same thing what we got with so much high calculus. Same. Okay, now we are talking about the kind of a yz plane and xz plane. Now there are other way to calculate it. Other way to calculate is consider that there is any point P. Now we'll go to the what we did in earlier. This is the simplest one. Simplest one is take any point and then take any two vector on the surface at that point and take the cross product of it and calculate the unit vector. That will be perpendicular. At least you can get the area vector direction. If not the area vector at that point, at least you will get the area vector at that because area vector has to be perpendicular at the surface. So take any point P and take any two vector that is touching the surface, any two vector. Typically, if this is a flat, then directly you can take. Like I took this origin as a point and took x-axis because one line is along x-axis. Another vector I took along another point that is 0, 1, 3 and calculated the cross product. It gives me the exact area magnitude also and vector also. Otherwise, if it is curve one, otherwise if it is a curved surface and at any point if you are trying to calculate area vector, then you have to calculate for this surface at any point then you have to take any two vector that is touching the surface. If it is flat, then you are lucky. If it is a flat, then just take a line and rotate it. Take line and register one vector equation and little bit rotate it and take the another vector. Now do cross product of this, that will be vector which will have some magnitude and direction will be exactly perpendicular to the surface. This is what you want as far as the area vector direction is concerned. But if it is a curved surface, if it is a curved surface, then how you will take two vector on the surface? Because surface everywhere, surface is different. Then we go with the xz plane and yz plane. Now take one vector in xz plane. Now it is clear. Now take vector, because if I take any point here and then I take a line at that point, then I can rotate 360 degree. All vector is at that point only. But in that 360 degree, in that 360 degree, take one vector in xz plane and take one vector in yz plane. You can take any two vectors, but kind of identify vector in only one vector that is falling in xz plane, and it should be tangential at that point. Okay, this is tangential at this point, knowingly, unknowingly. This is flat, that's why tangent is looking exactly touching the surface area. If it is not flat, then it will be tangent at that point. Similarly, if there is a curved surface, then I have to take tangent at that point. But tangent can be 360 degree. That is the problem. Which two vector I will take? Take a vector. If you are rotating like this at one point for the surface, take one is in xz plane. If this is x axis, this is y axis, this is z axis. Take one in xz plane and take another in yz plane and then do cross product of it. Since xz and yz are orthogonal to each other, you will get exact the surface area vector. If you are taking any two vector that is tangent here, you will get the area vector nicely, but surface area you will not get. Anyway, now if I take any position P, then dP by dx cross dP by dy, then you land up in the same scenario. dP by dx cross dP by dy. Here, if I take dP by dx, then what is position vector here? If this is origin, okay. Now dP by dx. Now, if this is origin, then I take this point. This is P. This is P. This is origin. What is P here? P is 1 comma 1 comma 3. P is 1 comma 1 comma 3. If I take dP by dx, where now, okay, d, okay, how I can say now? Okay, dP by dx. Now position vector, if I'm sorry, now take any point. If I take origin or any point, take any point P here, any point P here, dP by dx, the P position vector can be described as xi plus yj plus zk. dP by dx means I plus dz by dxk. Same thing we are coming what we demonstrated yesterday. I plus dz by dx k. I is I only, dz by dx k. Okay, dz by dxk. If I take any point, instead of this point, I take any point here. What is dz by dx? dz by dx. I plus dz by dx k. I by dz by dx k. Now, if I move in along the x-axis, how much z is changing? If I move along x-axis, z is not changing. Z is everywhere same. If I move along x-axis, you can see z is same, 0 only. If I take here, again, if I move along x-axis, z is same. Means this side are parallel to x-axis. So dz by dx is 0. Only I vector. dp in yz plane, we are taking another vector. If I see the the fundamental behind it, that if I am trying to calculate the area vector that is perpendicular here is, that will be, if I rotate it at this point, if I take a tangent vector can be in 360 degree. Any two vector I take and do cross product, I'll get the area vector. Area vector. Now to get the actual area, I take the orthogonal one. That is one in xz plane and one is in yz plane. Now in xz plane, I do dp by dx. In yz plane, I do dp by dy to get the tangent vector, not dz by dx or dz by dy. That is not vector. dp by dx will give, I believe this is different than what we had talked yesterday. Okay, so this is different in a way that we are trying to calculate area vector at any point. If I'm trying to calculate area vector at any point, then area vector will be perpendicular at that point, perpendicular to the surface area at that point. That surface area, if I take a tangent vector and rotate it at that point, then that it will form the surface area at that point. That this is surface area at this point, tangential surface. But these tangent vector are so many. Which two tangent vector I take? I take one tangent vector in xz plane. I take one tangent vector in yz plane, and then I do cross product, and that gives me area vector. For this, then if I do cross, if I see in xz plane, if I see in xz plane, then y is constant everywhere. So if I do dp by dx, then y is gone. Only will remain if in xz plane, if I take any position vector p, then variable are x and z because x is dependent upon x and y. If I do dp by dx, it becomes I plus dz by dxk. If I do dp by dx, then it is I plus dz by dxk. dp by dy, that is another line. Another line, the way dp by dx is the tangent in xz plane. dp by dy is tangent in yz plane. These are proved things. In that case, dp by dy will be j plus dz by dyk. Now, if you do cross product of these two, then you get the surface area vector. Or physically, you find two vector and do the cross product. So we found that since it was a rectangular region and it has two surface, two orthogonal lines. This vector is orthogonal to this vector. Either this falls in xz plane or in yz plane or somewhere else, wherever it is. This line, this line, and this line are orthogonal to each other. If they are orthogonal to each other, then cross product of these two will give the exact area vector at any point. Similarly, if it is not a flat line, then I'll make the two vector orthogonal to each other. That is only possible if I take one dp by dx in xz plane and one dp by dy in yz plane. That way also it is possible. But here I did not take in xz plane and yz plane. I was knowing that when these two are perpendicular to each other, directly I went with this vector and this vector, did the cross product, and it resulted in the surface area vector. Okay, but here to get the two orthogonal vector, I do a kind of a differentiation in one in xz plane and one in yz plane. dp by dx cross dp by dy. dp by dx is I plus dz by dxk. One is j plus dz by dyk. Someone can try now. If this is for this surface, if I take any point P here, any point P here, I plus dz by dz by dx is nothing, 0, only I, cross j plus dz by dy. If I move along y-axis, then height is growing. You see, if I move along y-axis, then height is also growing. But if I move along x-axis, then height is not growing. Height is same. Here also, height is same. But here, if I tilt like this, if I move along y-axis, height is changing. Okay, so here, this is y-axis. When y-axis, when y is 0, there is no height. But as I move along y-axis, height is growing. Okay, similarly, if I move, if I move along x-axis, then height is not growing. Height is exactly here only. Height is here only. But if I move along y-axis, then height is growing. So dz by dy is there, dz by dx is not there. So I vector cross j plus dz by dy k. Now this will give the area vector. I believe message is quite clear. If you want to, because all the discussion are going on how to find area vector. Calculating area vector is a big deal. It is difficult to find area vector for a surface where on the surface there can be infinite vector can be there. If I do cross product of any two vector, it will give me the area vector. Okay, for that, if the surface is not flat one, then I go with xz plane and yz plane because I know if I calculate dp by dx and if I calculate dp by dy, these two vectors will be certainly perpendicular to each other. Certainly. And that gives the area magnitude at that point, concrete, and then area vector. But area vector can be given by any two vector on the surface. So at any point on this curved surface, if this is point P, then this is tangent surface at this point. Now I drop it and stick with the tangent surface. If I stick with the tangent surface, then on this surface, there can be many vector on it. If I take any two vector here, this vector and any two vector, if I do cross product of it, then I get the area vector very nicely. But I want area also, not only the area vector direction, I want area also. In that fashion, I have to take two vector, those are perpendicular to each other. Then only I get the area vector nicely. In that sense, I take one area vector that is in xz plane. In xz plane, if I calculate the dp by dx, then exact in xz plane again there can be many vectors. I get this vector. Okay. Now another vector I take in yz plane. In yz plane, this is not yz. This is not yz. This is yz. This is x-axis, this is y-axis, this is z-axis. This is yz plane. Now if I rotate this yz plane, yz plane, yz, exactly it will stick to one of the vector if I am rotating this. It will one vector will fall exactly in yz plane. Similarly, if I keep rotating like this is x-axis, this is y, this is y, this is x-axis, this is y-axis, this is z-axis. In that sense, this is xz plane, 360 degrees. If I keep rotating this, then one vector will come that will be exactly in xz plane. Similarly, one vector will come that will be exactly in yz plane. That vector is dp by dx and dp by dy. But dp by dx must fall in this surface. dp by dy must fall in this surface. And since they are orthogonal to each other, I will not get only the area vector direction, I'll get the area also. That is exact A vector. And that plane I am talking about, this is tangent plane at that same point. So whatever area vector we are getting, that is at point P only. If we keep changing P, you will keep getting different area vector. That is algebra. Because algebra will take care of it. That is in function of x and y. That is the logic behind the normal logic behind the calculating the area vector. If you are stick with one surface only, there is one surface, there is no curved one, then directly you could take one vector along one direction and another vector along another direction, calculate the cross product of it. That is the area vector, that is area only. But if the surface is a variable surface everywhere, then you have to go with dp by dx cross dp by dy. If I take another point here, that will look like this. If this is the tangent surface at any point P like this, then here the surface area vector, the surface vector that is along the area is full 360 degree. Any two vector I can take to calculate the surface vector that is perpendicular. But I'll take one vector. Now if I keep rotating, one time will come when this vector will be exactly in the xz plane. Then keep rotating. One time will come, this vector will be exactly in the yz plane. Just hold on it. One vector and another vector. Now do cross product of it, you exactly get surface area vector at that point. So dp by dx cross dp by dy exactly give the surface area. So logic is the orthogonal vector at that point that we have to find. That's why we choose x XZ plane and YZ plane. I believe message is clear. Now we will try to do more example if possible. Otherwise, we will directly go into the kind of different coordinate system, cylindrical coordinate system, spherical coordinate system. And there we will proceed in the orthogonal differentiation, dp by d theta, dp by dr, dp by d phi, dp by dz, like that in other coordinate system to find the flux calculation. So the idea behind it is that the surface area vector, if I'm trying to calculate the tangent to tangent vector that are perpendicular to each other. That is not guaranteed that which two vector will be perpendicular to each other. Then get the dp by dx and dp by dy, that is one in xz plane, because xz plane and yz plane, they are guaranteed perpendicular to each other. Otherwise, if you know a surface that is a rectangular one, then one side and another side vector you get and take a cross product of it. Anyway, you get the area vector. Anyway, don't mind supporting us. +91 is the India country code. 9483160610 is the telephone number. 9483160610 is the telephone number. +91 is the India country code.